Welcome back, fellow shop rats. I'm here with my buddy Chris today. We are standing in the spot where our new piece of equipment goes. We've spent all morning moving about 6,000 pounds of machines here to the shop. We're in the machine shop. That should give you a clue. We're going to get things put in place, and today we're going to start. He's going to start. I'm just going to watch. Getting all of the things electrically done that need to be done. That's a hint. And there's just going to be a lot of cool stuff going on today, so don't go away. I'm Mike, this is Chris, and this is My Car Shop. So Chris is putting together some skate handles because we have skates and a big piece of equipment, and you probably already guessed what it is. We have a Bridgeport mill, and temporarily, because it's here to be repaired, we also have one big, huge lathe. This Cincinnati lathe has some problems electrically that Chris is going to work on. We think it has a hurt motor, so he's going to work on diagnosing that. Our objective today is to get these two pieces of equipment put in place, and then we'll start working on converting to 480 volts electrical to get them running. But the first piece of information, or the first thing we need to do, is move that 3,000 pound mill over there. So let's get that done.
Not quite.
Not quite. If we kick that out a little bit.
Not giving enough time to do it.
Okay. That should get you in there. I'm just concerned that one's over center, you know. And maybe it'll look right there. Okay.
Got it? Let me find out.
Yep, that works. I'm pretty close there now. I think we're okay. Yeah, I'm good. Yep. Perhaps I didn't want. Well, that wasn't super fast. It wasn't super easy, and they certainly aren't super clean.
But they got there.
Yeah.
And I'm glad we went slow because this floor is a little bit sloped and
Yeah.
it would have been bad to get pinched behind that thing and not be able to get out.
Yep. So we left that out about 2 feet from the wall right now so that he can get back and work on it, because this has a hurt motor. It's also got a bent motor mounting plate, which may be why that motor was binding, and maybe, you know.
Slowing something down.
Yeah.
The other thing is, though, that's really only a 3 horsepower motor, so it
Right.
may be the idea of the motor being weak might be that it wasn't made with a bigger motor.
Right. So the story behind it was when my nephew got it, he was told that the motor was weak and probably needed to be repaired. It's $4,000 to replace the motor. Chris will test it and find out if it's indeed that or if it's a mechanical issue or whatever. So that's coming. We got to level the mill now as soon as I can find my level. And that'll be the next step. Just get that thing roughed in for this point. So
I think what we're going to end up doing is basically building aluminum cribbing flat plates to just keep crabbing it up until we get it to where we need it, because the floor isn't necessarily level.
No.
The old trench here, so
This is a perfectly good floor. One thing we wanted to mention was if you're going to move equipment, these things weigh about 3,000 pounds each. If you're going to move equipment this heavy, Do it slow, like Chris said. Get as much as possible. Get the proper equipment to move stuff. Don't try to ham and egg it. This stuff will not only hurt you, it will kill you.
You can rent this equipment from a local rental shop. They'll have all of this stuff, the pinch dolly and pinch bars. You can rent all that stuff, and you're much better to do that. This is much more controlled than trying to move it with 4x4s and
Yeah.
stuff like that.
Stuff is top heavy. And, my little lathe over there is one thing. We can move that around the way we did.
Both
But
of us can horse that around. But something this big,
Yeah.
you might be able to push it and really rock it to go an inch or two, but not. You want to have something where you can pick this up in a controlled manner.
Yeah.
Because, like I say, steel always wins, and you don't want an argument about it.
Yeah, definitely. Okay, we're on to the next thing. So here we are, day 2 of the Bridgeport and Cincinnati machinery in the MKS shop. Chris is building the control panel right now for the 110 to 480 conversion unit that we're making. This is a controller to convert it from single to 3-phase, correct?
Yep. So what we're doing, if anybody really cares, is I've got a big transformer sitting over on the floor there that'll take us from 110 to 480. I've had that kicking around the house for probably 10 years or so. All of these parts came out of many old consoles and things that our shop was getting rid of, and I asked if I could grab it, and they said, sure. We can't resell it, we can't reuse it because it's already been used. This is old stuff. So I've grabbed it over the years, and this is the pile of crap I've got. So that will take it from 110 to 480. That will basically come into here, which is a big disconnect. There'll be fuses in there to protect everything. I've got breakers down here for some of the other things that I'm doing to make sure that there's always a safety in here. So if it starts a fire, if it blows up, if it does anything, this will help shut it down and contain it. That will route single phase over to here. This can take single phase and turn it into 3-phase, and it'll just come down here to these 3 wires. And this is where we connect up the machine. Like I say, this is all old used stuff out of old consoles that we were going to get rid of anyway. It was going to go into scrap bins or just get pitched or ground up, and the metals would be sacrificed out of it. And it's just stray stuff that was laying around. The shop said I could have, so here it is, trying to give it another purpose in life.
Go ahead, again.
So this will give us our single phase input, 3-phase output, and powers right off of here to run the machine. Eventually I'll get this tied into the controls that are already there, so everything will be a nice, smooth, soft start. It'll wind up in about a second, it'll wind down in a second, and it'll act seamlessly like 3-phase power would be for a normal machine if this were in a big shop that had 3-phase power to it. And this thing will work for either the lathe or the mill, and you'll just plug the one in you're using.
Talk about the difference between doing it this way versus using one of those
one of the
3-phase
cheaters
converters. Yeah.
Okay. I suppose the best way to think about it is that motor wants 3 phases because there's a total amount of power that needs to come into it to generate the power in the motor. When you use one of the cheater ways of doing it, you still only have a limited amount of power coming in, and the motor is being cheated. So a 1 horsepower motor doing it in a cheater style would not have 1 horsepower worth of power to it because you don't have the other 2 phases to build that power out of. Mm-hmm. That's also very hard on the motor to run it that way. So this puts the stress back into the drive, and this drive is big enough to be able to handle that increase in power coming in to make the little bit of 3-phase power going out. There's a bunch of different cheater ways to do it, but you always suffer because you don't have the real power, the real true power there to run the motor. These things really want to see 3-phase. They really want to have all 3 phases good. And if you don't give it to it, you're going to have problems. This way means that the stress is handled somewhere else. In this case, it's in the bridges in this that rectify it into, they take 3-phase power, they rectify it to DC, and then they switch that DC back into 3-phase AC. This will put the stress back here in this, which will take it all day long. Instead of putting it in the motor, which is eventually going to have a problem with it.
Which is what those single units, small units that go on a wall or whatever to take the 220 single to 223, that doesn't handle any of that stress.
Right. The stress is then put to the motor because the motor is now having to use basically part of itself to develop all of that horsepower.
Right.
This will also give us the ability to get true three-phase on any one of the motors, so we can look at the current distribution across all three phases and make sure there isn't a problem in one of the motor windings.
Right.
This will allow us to use that to check out these motors.
And theoretically, I mean, most of the time it's just me here, but theoretically, one unit like this would be able to run both machines with no problem at the same time.
This particular drive is heavy enough to run a much bigger motor than we're playing with here,
because we're dealing with a 3-horse.
Yeah, that's a 3-horse. That'll be about 5 amps draw on 3 phases over there.
And this is a 1-horse on the mill.
Yeah, this is a 1-horse. So this drive is capable of, I think it's 17.5 amps out. So that'd be a huge motor.
Yeah.
And this is meant, running it on something small like this, it'll just be loafing along nice and easy and not have a problem. They won't put extra undue stress in that bridge up front in order to suck in enough power for this to make it into 3-phase output.
And the draw of that transformer being 110 to 480 is really no much more than my 110 welder would be.
Right. If you did the math, it's a 5 kVA transformer. So at 5 kVA, if you were drawing everything through there to get the full 5 kVA on it, so 5,000 divided by 120, that's 41.6 amps.
Yeah.
That's downhill, 300 mile an hour tailwind. Everything you could draw through that would be 41 amps.
Mm-hmm.
And we can get that out of one side, out of one phase out of your panel. That converts to 5,000 divided by 480. That gives us 10.41 available amps out of that in order to feed this. And we won't be using all of that in order to generate the 5 that we need for the one, or the, less than 2 for the other.
Well, he's doing the electrical. We thought it would be appropriate that he's playing with electricity and I'll be playing with water. What could go wrong?
Yeah.
I'm going to start the process of just getting this cleaned up. So we have various cleaning stuff, brushes, scrubbies, and of course, super clean to make it super fast and super easy.
Yeah.
Hopefully when we're done, it'll be super clean. But Chris also brought a sharpening stone, I should say.
And this is just your regular, I mean, go wherever, pick up a regular 2-part stone. One side's coarse and one side's medium. Don't necessarily need down to the really fine stuff. An oldie-timey machinist once showed me how to do this. It's called an oil stone because you always put oil on it, but the idea is the oil floats the debris. It keeps it from gumming up the stone. And that stuff also, in that mix of oil, becomes a lighter abrasive to help you use the crap that's there to actually clean up the crap that's there. But it's just a regular stone, and you're going to run it in nice, big, gentle circles. You don't want to push too hard on one side or the other, so you want a nice, big, broad, flat surface. And in working on something this size, that's why you're using a big stone like this. I mean, you can see all the crud here. That's all emulsified oil and dirt that is collected on the machine over time, and you really don't want to run that through all of these really delicate ways. So you clean all that crap off of there, and then you lightly go over those surfaces with a stone to make sure that there are no burrs or no little pockets or hiccups in the surfaces, and this will help clean it all out of there and work it out of the surface. So by the time it'll be super fast and super easy to run this over with super clean. That'll get rid of most of the dirt, and then you go back and work those surfaces that you're going to be working on and clean them down with a stone to get rid of all of that, and this will turn nice back, shiny bright. You won't recognize this thing by the time it gets done. I mean, all the dirt up here and all of that, yeah, it's all great to move that off, but these working surfaces down here are going to need to be cleaned. That way there's nothing that's getting dragged in there on all those ways. All that's going to need to be adjusted and worked through. We got to tram the head into the table, and lots of work to go. But this will be actually a really nice project to have on here.
See, Jessica, we're always thinking about you. So here we go, just with a before shot of just how dirty this thing is. We're going to contrast that with what it looks like when we're done. And that may not be totally done by the end of this video, but it'll be a significant improvement for sure. She's a grimy thing. But, you know, it was in the factory, in their model shop, I believe, for years. And then my nephew got it, and it sat in his tool shed for 10 years probably, not being used. And so, you know, that's why it's here, is he said, hey, take it, use it. Somebody needs to take care of it, and I'm not. So it all works out.
So you can feed it and exercise it and keep it in good fighting trim. And then
It's being stored here with the idea that I will maintain it, and then I get to use it. So I'm just basically starting at the top, and then as I wash this down, stuff will wash down over the other parts that need to be done and help break things up, and et cetera, et cetera. Of course, we're trying to stay away from the DRO and all the electrical stuff, but you can see the Super Clean is biting in already and making a difference. So get my little scrubby brush and get after it. Sometimes when you're working in the shop, you leave the doors open and stray animals show up, and some of you will know who this is, and if you don't, well, go back and watch the 413 episodes, because you'll know. We have been out here all day. Chris has been working super hard on getting the electronics done. We'll get to that in a minute. What I have been doing is making it, well, I've been making it super clean. I wouldn't say it's been super fast or super easy. It's not because of the product. It's just this thing, it was dirty. So let's see what we got.
But no, honestly, I suppose it was kind of super easy and super clean, because that was the funk of 40,000 years on this thing.
Well, that's true.
And it was honestly just washing off.
That's true. It was, I mean, oh my God, it was, yeah, it was a mess.
Yeah.
Let's see what we got.
Okay, just to point out, this is actually the original mill. We did not move the old one out and put this one in. This really did clean up like this. This is absolutely amazing. All of the numbers on the dials and all the body, everything is all originally there, and this is all cleaned down. Everything is just as gorgeous.
So the next step now is we have our 480 transformer. We're going from 110 volts to 480 volts, single phase, coming into the controller and the Voodoo that Chris do so well. And our A1000, what is that? How do you say it?
Yaskawa.
Yaskawa controller that takes it from 480 single phase and converts it to 500, 600 volts DC.
Yeah, it was like 630 or 40 volts. And then it takes that big bus, that big volume of energy stored in the capacitors, and it switches it back over into three-phase. So you've got all three phases, all the power would be balanced, everything would be, the idea is that what it's sending to the motor is exactly what the motor wants to see, but it's taking, the stress of doing this is all taken up in that transformer and the single phase coming into here. It draws more current on single phase, and it gives exactly what the motor wants to see. So there's no stress of only running on part of the motor. Everything up here sees exactly what it wants. Everything runs nice and smooth and beautiful. That's the idea of what we're trying to do here.
So we're going to get this mounted in the fire cabinet, and then we'll see if it works.
So the drive is starting up and the drive is idling away. It's turned on and it's actually running. We're in remote mode, or sorry, local mode, and run. Now I'm going to come back at some point and we'll redo this to incorporate those controls into this. We'll bypass all of the box down below and take this directly to the motor, so that all of the push button over there works down here and just gives you smooth, seamless control, forward, reverse. It will control everything. You could even be spinning full speed one way and throw it the other, and it'll just slow down, stop, and then take off the other way. So everything should be good. And let's see about giving a...
By the way, we got our DRO running.
So there's reset, and there it goes. Now I'll pull out my other meter and I'll take a check on all three phases and make sure they're balanced and see what kind of current we're actually drawing from the wall. But I can't think it'd be much more than 5 or 6 amps, and everything would be...
So we're running off of a 110 volt circuit, 120 volt circuit out of the wall on a 20 amp breaker into the 480 step up transformer to bring it from 110 to 480, and then over to the controller to take it from 480 single phase to 480 three phase, which is now running our machine.
And we should be able to... It slows down and stops. And there's reverse. So now everything's working. That's beautiful. And all of these,
Yep.
all the locks still work. You've got all your adjustments. And then
Yep.
a DRO is working. And this one should be working as well.
Yep. They both are. I checked them earlier, so I was concerned after all that washing that.
Oh, there. That was the...
Yeah, I tightened it up. It needs a be run to each end and cleaned, but
Yeah, and was this still... Oh, good. That's tightened up, too.
Yep.
There may be they may have left that loose because there might be a slight misalignment in there that needs to be corrected for.
that could be. Yep, that could be why.
And that's why they always left it loose. Just live with the backlash. Leave it loose.
Which is fine. It's
There. It's running.
we haven't made any chips yet, but there's still a ton of work.
Oh, yeah. There's the ways and all the lubrication. And the lube pump seems to work, and it's still got oil in it. And
Yeah, we probably need to change that oil out.
Yeah.
Get some fresh in there because that oil is probably 20 years old.
yeah, that needs to be drained and
Yep.
refreshed. And
We
And-
haven't looked at the belt to see what's going on up there yet, so we should look at that at some point. But it's all little things at this point. So
that's all there. It's running. It's spinning.
it's a dream come true for me, and thank you for. We would have been running off of a 220 converter, running on half the horsepower or less, and
Yeah.
so this makes it way.
This gives you full power,
Yep.
and you can pull every chip, and you can do everything this thing was meant to do. Nice and balanced. No heat problems. No single phase problems. You got all your horsepower. So
Yeah, Becky commented when she came out. She said I expected to see the lights flickering in the house, so it's only drawing 5 amps on 120.
it was 4.7 amps.
Yeah.
To give 2 amps on all three phases as 1 point.
Yeah, it was under 6.
Yeah.
So that's awesome. Thanks.
There.
All right. Well, that'll do it for this one. We're beat. This has been an exhausting weekend of 2 days of nothing but working. We didn't get to the lathe yet. We've kind of diagnosed some issues with the lathe. The motor mounting plate is bent, which means we have a drive alignment problem, which could be why it was losing a lot of power and seemed weak. Plus, it's a small motor, so that's another project for another time. We're going to continue. I got a mouse in my pocket. Going to continue moving forward on this, and at some point, you'll see me just fooling around making some chips.
You need a new battery.
Oh, my Mitutoyo is, we need to put a battery in that. So, all right. Thanks for being here. This has been a ton of fun, and we're going to go kick our feet up. And I think she's got spaghetti for us. Beck made supper tonight.
There we go.
All right. All right. We'll catch you on the next one. Don't forget.
Yeah.
Rock!